What if I told you that a tiny, frozen rock hurtling through space holds the answer to one of humanity's biggest questions? Where did we come from? And here's the thing that's going to blow your mind. NASA just brought back something from an asteroid that scientists never expected to find, something that challenges everything we thought we knew about the origins of life itself. Stay with me, because by the end of this video, you're going to question whether Earth was really the birthplace of life or if we've been looking in the wrong place this entire time. The answers to some of our solar system's oldest mysteries are locked in dust and ice. Asteroids. These ancient time capsules have been floating through space since before Earth was even fully formed. Think about that for a second. Before dinosaurs, before oceans, before life itself, these rocks were already out there, silently drifting, carrying secrets from the very birth of our solar system. And if we can uncover what lies within them, we can finally understand our own origins. We can understand where we came from, where life came from, and maybe, just maybe, where we're headed. So naturally, NASA has launched countless missions to image these mysterious objects. They've even collected samples from the tails of comets, scooping up stardust like cosmic treasure hunters. But here's where it gets insane. There has only ever been one NASA mission that traveled to an asteroid, touched its surface, and brought a sample back to Earth. Just one. And most people have never even heard of it. I'm talking about OSIRIS-REx. And trust me, this mission was unlike anything NASA had ever attempted before. The journey to an asteroid called Bennu was not smooth sailing. Far from it. In fact, what they discovered when they got there, and what happened when they tried to collect a sample, shocked even the most experienced scientists at NASA. Some are even calling it the most important sample return mission in human history. So, what did OSIRIS-REx do out there? What were its mission goals? And what did this NASA mission ultimately uncover on that tiny, frozen world? By the end of this video, you're going to see asteroids in a completely different light. And you might start questioning everything you thought you knew about life on Earth. Stick around, because this story is absolutely wild. Let's start from the beginning. OSIRIS-REx is part of NASA's New Frontiers program. You might have heard of the other missions in this program. Juno, the spacecraft studying Jupiter. New Horizons, which gave us those stunning images of Pluto. So yeah, OSIRIS-REx is part of a seriously high pedigree lineup. It launched in September 2016, and after a 2-year journey through the void of space, it arrived near the asteroid Bennu on December 3, 2018. And immediately, it started imaging the surface. But here's the thing. OSIRIS-REx isn't just some fancy camera floating around in space. Unlike most robotic NASA missions that never return to Earth, OSIRIS-REx is unique. It's a sample return mission, the first time NASA would ever attempt this with an asteroid. Now, I should mention that Japan's JAXA program had already done this before with their Hayabusa missions, Hayabusa 1 and Hayabusa 2. So NASA wasn't the first. But that doesn't make this any less groundbreaking. But hold on, why asteroids? I mean, apart from the cool factor, is there anything that actually makes asteroids special? Well, here's where it gets interesting. Asteroids are remnants of some of the oldest objects in our solar system. They were there when everything was in the process of forming around the sun, 4.5 billion years ago, before planets, before moons, before Earth had oceans or an atmosphere. These asteroids were already there, witnessing the birth of everything. So asteroids can tell us a lot about the formation of the solar system. They are literally the building blocks of planets. And get this, they might also be the building blocks of life itself. Scientists believe that asteroids could be the source of water on Earth. Think about that. The water you drink, the oceans you swim in, might have originally come from asteroids crashing into our planet billions of years ago. And here's the kicker. Asteroids mysteriously contain organic materials, hydrocarbons, amino acids, the very ingredients needed for life. Now, before you comment, yes, I know what you're thinking. We have meteorites here on Earth. Tons of them. Why not just study those? Well, here's the problem. Meteorites that land on Earth pass through our atmosphere, heating up to incredible temperatures. This process alters the delicate materials inside them. And then, upon impact, they're exposed to Earth's environment. Water, oxygen, bacteria. This makes it nearly impossible for scientists to distinguish what was originally there and what got contaminated after landing. But a sample collected directly from an asteroid, protected in a sealed container during re-entry, that's a game changer. With an uncontaminated sample, scientists can search for organic compounds like amino acids, hydrated materials like clays, and other substances that would otherwise be impossible to detect. This is why OSIRIS-REx is so important. Now let's talk about Bennu. This asteroid is extremely old. It's been floating around since the birth of the solar system, 4.5 billion years. That makes it a treasure trove of information about how our solar system formed. And maybe, just maybe, it holds clues about the origins of life itself. So NASA made a bold decision. While missions had photographed asteroids before, and some had even collected stardust from comet tails, this would be the first time a NASA spacecraft would physically touch an asteroid and collect a sample from its surface. The stakes were incredibly high. NASA's goal was to collect at least 60 grams of regolith and dust from Bennu's surface. That's about 2 ounces. Doesn't sound like much, right? But getting it was going to be anything but simple. The plan was for OSIRIS-REx to enter Bennu's orbit and slowly descend. And here's the tricky part. It had to be extremely careful not to disturb or contaminate the asteroid's surface. No crashing, no bouncing, just a gentle touch. To do this, OSIRIS-REx would extend its long robotic arm. It's called the Touch Dash and Dash Go Sample Acquisition Mechanism, or TAGSAM, or TAGSAM for short. Quite a mouthful, right? So the spacecraft would drift down gently, extend its arm, and at the exact moment it touched the surface, it would release a burst of nitrogen gas. This gas would kick up dust and materials, which would then be captured in the sampler. Simple, right? Well, not exactly. And here's the clever part. Once OSIRIS-REx collected the sample, it had to figure out how much material it actually grabbed. But how do you weigh something in space? There's no gravity to use a scale. So NASA came up with a brilliant solution. The spacecraft would perform a spin maneuver and measure the change in inertia. Basically, it would see how much harder it was to spin with the added weight. If it didn't collect enough, it would go back and try again. So OSIRIS-REx began its journey. Now, even though Bennu is considered a near-Earth asteroid, it still took more than 2 years to get there. Why? Because Bennu doesn't orbit along the same plane as Earth. Its orbit is tilted. Plus, its gravity is incredibly weak. If OSIRIS-REx approached too fast, it would simply overshoot and fly right past it. So the spacecraft had to slow down, a lot. Here's something fascinating. The OSIRIS team actually had a pretty good idea of what Bennu would look like long before the spacecraft even launched. How? They used radar data to create simulations, detailed predictions of the asteroid's shape and surface. And as OSIRIS-REx approached Bennu, sending back progressively clearer images, the team realized something shocking. Their predictions were surprisingly accurate, almost eerily so. Eventually, OSIRIS-REx got to within 20 kilometers of the asteroid, and what it saw was absolutely amazing. This is an actual time-lapse of the Bennu asteroid as seen by OSIRIS-REx. If you compare the simulation to the actual photographs, it's incredible how spot-on their predictions were. But as the images got clearer, something else became apparent. Bennu was not a smooth asteroid, not even close. It was covered with rough regolith all over the surface. It reminded scientists a lot of another asteroid that was visited by Japan's Hayabusa probe, the asteroid Itokawa. That one looked more like a clump of rubble than a solid rock. And Bennu, same deal, but with a twist. Bennu is about 500 meters in diameter. That's roughly 5 football fields across, and it has this weird spinning top shape. Why? Scientists think it's because Bennu has low gravity, but a fast rotation. So regolith, the loose rocky material on the surface, has accumulated along its equator as the asteroid spins, kind of like how a spinning pizza dough spreads outward. Now Bennu is what's called a carbonaceous asteroid, but it's not just any carbonaceous asteroid. It's classified as a B-type. This is rare, really rare. It puts Bennu in the same category as Pallas, the third biggest asteroid in the solar system. In fact, scientists think Bennu could actually be a projectile from an ancient impact on Pallas. Imagine that. Billions of years ago, something massive slammed into Pallas, and a piece of it was flung out into space. That piece became Bennu. And here's another interesting detail. B-type carbonaceous asteroids have a very low albedo. What does that mean? It means they don't reflect much sunlight. Bennu is dark, really dark, almost black. Some tests even suggested that Bennu might be an even rarer F-type asteroid instead. If that's true, it could have come from the Polana family of asteroids, meaning it broke off from a 55-kilometer wide asteroid called Polana. Either way, Bennu's orbit has changed significantly over billions of years through various gravitational interactions, eventually bringing it close to Earth's orbit. And speaking of its orbit, here's something that should get your attention. Bennu is one of the most likely asteroids we know of that could impact Earth. Let that sink in. Now, before you panic, this won't happen anytime soon. Based on the most recent estimates from 2014, the earliest it could happen is 2175. And even then, there's only a 1 in 2,700 chance of it actually hitting us. So we're safe. For now. But it's still unsettling to think about, isn't it? Let me know in the comments if you think we should be more worried about asteroid impacts. I'm curious what you think. Before OSIRIS-REx could enter orbit around Bennu, it had to make sure there were no surprises, no small moons, no debris, nothing that could cause a collision. So the spacecraft made several passes around the asteroid, back and forth, scanning for hazards. It was also getting a sense of the gravity of such a tiny object. And once the team confirmed it was safe, OSIRIS-REx took up its initial orbit, about 1.75 kilometers above Bennu's surface. And here's a fun fact. This made Bennu the smallest world ever to be orbited by a spacecraft. Ever. Think about that. A 500-meter wide rock, barely held together by its own gravity, and we managed to orbit it. But here's the thing. Bennu's gravity is so weak that one orbit took 62 hours. That's over 2.5 days just to go around once. On Earth, the International Space Station orbits our planet in about 90 minutes. The difference is staggering. But orbiting Bennu was absolutely necessary. Why? Because NASA needed to map its surface accurately. As the spacecraft orbited and the asteroid slowly rotated, OSIRIS-REx was constantly scanning the surface. And the result? The highest resolution map of any celestial body to date. Higher resolution than maps of the moon. Higher than Mars. This tiny dark asteroid now has one of the most detailed maps in the entire solar system. So did OSIRIS-REx find anything interesting during these preliminary scans? Oh, absolutely. The spacecraft wasn't just taking pretty pictures. It was mapping the global properties, chemistry, and mineralogy of this primitive carbonaceous asteroid. It was characterizing its geologic and dynamic history. Satisfied with this run, scientists sent it in again. On August 11th, OSIRIS-REx approached even closer, this time down to 40 meters. Once again, it pulled back. Slowly, carefully, darting forward and backward like a heron preparing to strike, drawing ever closer with each pass. And then on October 20th, 2020, the moment everyone had been waiting for finally arrived. Using onboard computer systems to plan its trajectory and perform its operations, because the time delay for signals from Earth made real-time remote control impossible, OSIRIS-REx went in for the final approach. The spacecraft raised its solar panels into a Y shape to keep them out of the way and protect them from any loose dust that was about to go flying. It extended its robotic arm, and it descended toward the surface of Bennu. It reached out, it touched the surface, and then something shocking happened, something nobody expected. The spacecraft kept going. It didn't stop. The arm sank into the surface, deeper and deeper. Now, when you think of the surface of asteroids and comets, you probably imagine them as firm and solid, hard enough to stand on, like in the movie Armageddon, where Bruce Willis and his crew are drilling into an asteroid. But the truth is completely different, especially for small asteroids like Bennu. Their low gravity means that their mass is only loosely held together. What looks like a stable surface is actually loosely held material interspersed with pockets of empty space, gaps, voids. If you tried to step on Bennu, you wouldn't stand on it. You'd sink into it, like stepping into foam. And that's exactly what happened to OSIRIS-REx. The robotic arm sank almost half a meter into the surface of Bennu. Imagine that. The spacecraft was disappearing into the asteroid. The thrusters kicked in, frantically trying to arrest the fall. And then, right on cue, the nitrogen gas burst activated. A powerful jet of gas blasted into the surface, kicking up material. But what was expected to be a small puff of dust turned into an absolute explosion. The gas displaced over 6 tons of loose rock. 6 tons. Material that was so loosely held under Bennu's tiny gravity was catapulted in all directions. A massive cloud of debris expanded outward. Osiris-Rex's thrusters went into overdrive, burning harder than they had ever burned on this entire mission, desperately pulling the spacecraft away from the expanding cloud of dust and rock. Of course, all of this was pre-programmed. NASA had planned for something like this, although maybe not to this extreme. Osiris-Rex had just created a brand new massive crater in the side of Bennu. The asteroid's surface was permanently changed. Once the spacecraft got away from the surface and stabilized, it checked its haul. Remember, NASA's goal was to collect at least 60 grams of material. That's it, just 60 grams. But when Osiris-Rex analyzed what it had captured, the team couldn't believe it. The spacecraft had collected somewhere between 400 grams and over 1 kilogram of material. That's almost 20 times more than the minimum goal. But there was a problem. So much material had been collected that a rock got stuck in the flap that was supposed to seal the sampler's head. This caused some of the material to slowly leak out into space. Scientists watched in horror as precious samples drew away. But thankfully, Osiris-Rex was able to transfer the sampler head into a sealed container built into the spacecraft before too much was lost. The mission had been a massive success. For a time, Osiris-Rex stayed near Bennu, flying over the asteroid to image it and see the outcome of what it had done. The surface of Bennu was different now, dramatically different. Even large boulders had been thrown across the surface. One boulder, about 12 meters across, had been flung a significant distance. The crater that Osiris-Rex created was clearly visible, a scar on the surface of an ancient world. But Osiris-Rex couldn't linger forever. Its sample needed to get back to Earth. And so, after performing one last flyby on April 7, 2021, the spacecraft fired its thrusters and began the long journey home. It had been a long time since Osiris-Rex left Earth. 7 years of anticipation. 7 years of space travel, data collection, and sample gathering. But after a 2-year and 4-month journey home, covering 1.9 billion kilometers, Osiris-Rex finally returned to Earth in September 2023. Or rather, it passed by Earth, because the spacecraft itself wasn't coming back. Only its precious cargo was. As Osiris-Rex reached a point about 100,000 kilometers away from our planet, it jettisoned the sample return capsule toward the atmosphere on September 24, 2023. Then the spacecraft fired its thrusters to avoid colliding with Earth and began a brand new mission. But we'll talk about that later. This maneuver had to happen within a narrow window of time and at exactly the right angle. Why? Because the return capsule needed to hit a specific target. A patch of desert in Utah, in the western United States, roughly 600 square kilometers in size. That's about the size of the city of Chicago. Or if you're from the UK, about the size of the Isle of Man. Miss that target, and the sample could be lost forever. As the capsule hurtled toward Earth, it was moving at a top speed of 43,000 kilometers per hour. That's over 26,000 miles per hour. To put that in perspective, this made it the second fastest human-made object to ever enter Earth's atmosphere. Only 3,000 kilometers per hour slower than NASA's Stardust return capsule. And during re-entry, the capsule experienced an astounding 32 g-forces, 32 times the acceleration due to Earth's gravity. Let me put that into perspective for you. Standing on Earth, you experience 1 g. A typical person would lose consciousness at about 4 to 5 vertical Gs. Astronauts during launch experience about 3 Gs. A fighter pilot with specialized training in a G suit might be able to withstand up to 8 or 9 Gs for very short periods of time. 32 Gs is almost unfathomable. It's a miracle the capsule held together. The scalding hot capsule streaked through the atmosphere like a meteor. It reached peak temperatures of around 20,700 degrees Celsius. That's about half as hot as the surface of the sun. Ground-based infrared trackers monitored its fiery descent. But inside the capsule, the sample from asteroid Bennu was completely protected from these extreme temperatures. How? Thanks to an advanced thermal protection system called PICA, phenolic dash impregnated carbon ablator. PICA is a type of ablative heat shield. It works by using a protective layer on the outside of the spacecraft to safeguard it during re-entry. As the spacecraft experiences extreme friction on its way down through the atmosphere, it generates immense heat. The heat shield heats up, and its outer layer begins to burn away in a process called ablation. The shield melts and vaporizes, and those gases carry the heat away from the spacecraft. It's a sacrificial shield. It destroys itself to protect what's inside. And it worked perfectly. PICA removed more than 99% of the kinetic energy of the vehicle and kept the sample below 75 degrees Celsius. A couple of minutes after re-entry, the capsule had slowed down enough to release the first of 2 parachutes. This helped to stabilize it for the remainder of its trip to the surface. About 16 kilometers from the ground, radars locked onto the capsule's location and tracked it to within about 10 meters of where it would eventually land. And for the final kilometer and a half of descent, a second parachute deployed. This softened the landing to a leisurely speed of 18 kilometers per hour, about the average speed of a cyclist on flat ground. From the moment the capsule pierced Earth's atmosphere to when it gently touched down in the rugged desert landscape of Utah, the entire process took just 10 minutes. 10 minutes. After 7 years in space, the sample from Bennu was finally home. Now here's where it gets even more intense. After years of planning, months of special training, and several rehearsals, the NASA recovery team was ready. As soon as the capsule landed, helicopters moved in to secure it. Speed was critical. Why? Because the sample needed to remain completely uncontaminated. To ensure this, the capsule stayed sealed until after it had been moved to a clean room and thoroughly decontaminated. But once they opened it, what they found inside changed everything. If you want to know what NASA discovered in that sample and why it's causing scientists to rethink the origins of life itself, make sure you're subscribed to the Curiosity Beast, because we're going deep into this story. Drop a comment below and let me know. Do you think life on Earth came from asteroids, or did it start here? I want to hear your thoughts. And stick around, because what comes next is going to absolutely blow your mind.